I wanted to do a quick review of combining functions with some really important examples. So the first thing is we learned how to add functions. F plus g of x, this is the input, is the same as adding f of x plus g of x, just adding the two functions together. And to find the domain, remember you find the domain of f and you find the domain of g, and then you find their intersection. So this first example is just a domain example. Let's say we already know the domain of f is everything but 5, and the domain of g is from 3 to infinity. Then what would the domain of f plus g be? Well, if we draw a number line and we put 3 in and 5 in, and remember I said if it's a domain where it's just a hole, then do that first, because then you can mentally shade everything else. And then 3 to infinity is an open circle on 3 because of the parentheses and to the right, but we already know we have to skip over 5. So the domain of f plus g is parentheses 3, comma, 5, parentheses, union, 5, comma, infinity, parentheses. Okay, example 2 says find f plus g and the domain given these functions. Okay, so f plus g simply means add the two functions together. So f of x would be the square root of 9 minus x plus, and then g of x is the square root of x minus 4. And you can't add radicals together, so you're done. But what messes people up is sometimes they don't remember. Remember, we're just creating a new function. So they'll keep going and they'll put another equal sign and set it equal to 0. Well, an equation can't have two equal signs, and that's not what you do. You're just creating a new function. Now, to find the domain, remember, we need to find the domain of f. So what's under the radical, we set greater than or equal to 0, and we get x is less than or equal to 9 when we divide by that -1. Over here, x plus 4 greater than or equal to 0, and we get x is greater than or equal to -4. So both of these have to be true. So if we draw a number line, I'm sorry, that should be x minus 4, therefore 4. Okay, so if we draw a number line, we have a 4 and a 9, and it has to be less than or equal to 9, but also greater than or equal to 4. That's going to leave just these numbers in between 4 and 9. So the domain of f plus g is bracket 4, comma 9, bracket. Example 3, f plus g of 5 using the functions in example 2. Okay, so this is a good example because this is my input 5, and if I give you the one input, then you don't need to worry about the domain. And this is actually an easier problem. You just have to remember that f plus g of 5 is the same as f of 5 plus g of 5. So f of 5 means square root of 9 minus 5, and g of 5 is the 5 minus 4 square root. So that gives me square root of 4 plus square root of 1, or 2 plus 1, or 3. So if I give you the input, remember to split that into two different functions and then add them together. And don't worry about the domain because you don't care about all the x's. There's only one, and it was given to you as 5. Alright, subtracting functions. Remember, f minus g of x is f of x minus g of x, and here is our example. And I've changed this problem that you might have on your notes to g of x is x squared plus 4, and I'll show you why. This is a major error. When you're subtracting two functions and you want to find f minus g of x, remember f minus g, when there's nothing after it, it means f minus g of x, is the same as f of x minus g of x. So we're going to substitute f of x in, use parentheses, minus g of x, use parentheses. Because this minus causes all sorts of trouble throughout the semester, it belongs to both of these terms, and if you don't use parentheses, then you'll forget to distribute it. And the parentheses don't hurt. If there's nothing out front, you just write this down without them. Okay, now we're going to distribute the negative, so that'd be minus x squared. People never miss that part. It's the minus 4 part. They forget to distribute the negative to the 4. So then you'll add like terms, and that x squared minus x squared is 0, and you get 2x minus 4. So f minus g of x is 2x minus 4. Now the domain here would be all real numbers, and the domain here would all be all real numbers, so the domain is simply all real numbers on this one. Example 5, okay, it's just like example 3, except it's minus f minus g. This is not times, this is f minus g of negative 2. The input is negative 2. So this is the same as f of negative 2 minus g of negative 2. And again, let's practice using the parentheses because of all of these negatives. So f of negative 2 is negative 2 quantity squared with parentheses around it plus 2 times negative 2. That's f of negative 2. Okay, so we'll figure that out. That's 4 minus 4, that's 0. So f of negative 2 is 0. Okay, I decided that I didn't want to continue this line because of this minus here. So let's just find g of negative 2 separately. So g of negative 2 is negative 2 parentheses squared plus 4. So that would be 4 plus 4. So that would be 8. Okay, so g of negative 2 is 8. But we want to find f of negative 2 minus g of negative 2. So that would be 0 minus, that's that minus, parentheses 8. And I'm being really obnoxious with the parentheses because I want you to learn to use them. So since there's only one number in here, that's just 0 minus 8 is negative 8. But if there were two numbers in there or a expression, you would have to distribute that negative. Okay, now multiplying functions. Say we have to find f times g, and f of x is square root of 9 minus x, and g of x is square root of x minus 4. So same functions as in example 2. So f times g means f times g of x, which means f of x times g of x. It just means multiply both the functions together. So that would be square root of 9 minus x times the square root of x minus 4. Now, if you remember back up at example 2, we couldn't really add the radicals together. Adding is always more complicated than multiplying. You can actually put both of these under one radical. When you're multiplying two separate radicals together, they can go under one radical. All right, now this is going to have an interesting domain, but we've actually already found it, because remember, to find the domain of adding, subtracting, or multiplying, you find the domain of one, you find the domain of the other, and then you find the intersection. So this one has the same domain.